Hello students. In this video mini lecture, I am going to talk about machine level language, assembly language, and finally high level computer programming language, for example like C. So the first thing you need to understand is computers only understand ones and zeros. That means ultimately you got to talk to the computer in terms of binary digits. First, before trying to understand what is machine level language, let's try to understand what is a program. A program is a set of instructions in a proper sequence having a definite ending and getting over in a definite amount of time. Now, what happens in a normal computer is the instructions are executed by the central processing unit or the CPU. So, what does the CPU tend to do is it gets the instruction. Okay, it tries to decode or understand the meaning of that instruction, what that instruction says. For example, whether it says add, divide, multiply, and so on. And after understanding the instruction, then it sees that the instruction is executed by getting different parts of the computer to coordinate and get the work done. So the job of the CPU is to execute instructions written in a program using data to achieve some end goal. For example, your end goal could be trying to calculate the factorial of a number. So using your instructions and data, which happens to be an input number, you're going to carry out and do the work. Now, in computers, you have to use only ones and zeros in the modern digital electronic computer. Basically, 1 is represented by on and 0 means off. Internally, what it means is in a magnetic media, it can mean 1 can mean say that particle is pointing north and 0 can mean that particle is pointing south. Or in case of a voltage, 0 can mean 0 voltage and 1 can mean 5 volts. So that's how you represent internally ones and zeros. Now I have a small bit of an assignment for you. I would want you to do some discovery as to why the decision was made to use binary numbers in modern digital electronic computers and why not decimal number systems were chosen to be used. What I will do is give your answers in the comment section. The best answer shall be put by me at the top of the comment, okay, indicating that this is the best answer, maybe the second best and third best also, and the other comments which are not relevant or which are not perfectly right may be deleted so that the comments doesn't go too long. So I appreciate if you can go ahead, do some discovery as to why binary numbers or only ones and zeros are used in modern digital computers and not a base 10 or a decimal number system is used. So let's now talk about machine level language. So the way to understand a machine level language is, as I told you, a computer ultimately talks or understands ones and zeros. If you are able to talk in terms of ones and zeros and get things done from a computer, that particular language is known as a machine level language. Here, the instructions or the directions are written only using ones and zeros. Next, what happens is the challenge with machine level language is machine level language will change from one computer hardware to the other. For example, the instruction which works on an AMD processor may not work on an Intel processor and will surely not work on a ARM based processor. The reason why machine language differs from computer hardware to hardware is, if you remember in one of the previous lectures, I told you the word size of a computer can be 8, 16, 32, 64, 96 and so on. So say for example you have written instructions and code which works on an 8-bit microcontroller like on your smartphone, there is zero chance it is going to work on your PC which is maybe using an AMD processor or an Intel processor. That's why for hardware to hardware the machine level language is going to change, because the way the computer operates or the way the architecture or design of the hardware is different for smartphone, different for PCs and different from other smart appliances. Okay, so that's why it is different. Machine language, since you're exactly writing what you want, it is obviously going to be the fastest in terms of execution, because you're not going to write anything extra which is not required. But it comes with its own challenges. The first challenge is, since this language involves only ones and zeros, instead of a 1 if you write a 0, or instead of a 0 you write a 1, you're going to make a mistake and you're not going to get the correct output. Writing long program in machine language is extremely difficult, because you are 100% bound to make mistakes, and it is very difficult to find out the mistake because you are talking only in terms of ones and zeros. Now let me show you a dummy example or a conceptual idea of how a machine level language instruction and data or code looks like. Say for example, okay, I want to give an instruction for the CPU to stop or halt. So 00 could be my code to indicate for the CPU to halt. For start, the code may be 001. If there is an error, I may give an instruction 1111. If I want to give an add instruction on a dummy or a assumed machine level on a machine using machine level language, it may be 1010. So these are English like words. These are actually what I will be writing in a dummy or a assumed machine level language. I would request all of you, in the description there's a beautiful link, okay, by a university. I'm not sure what is the name of the university. They have shown using an app on your browser. On the right side there's a light bulb. If you tap on the light bulb, it will execute a series of machine instructions one by one every time you tap it. In that they show you how the bulb is put on, how the bulb is dimmed, how the bulb is switched off using machine level language. So I request all of you, please go to the description, look at this link which you can see here, click on that link, and once it opens up in your browser, read what is written on that page and click on the light bulb to understand how a machine level language works in your computer, or how it is supposed to work. So after I have spoken about machine level language, now I told you about the disadvantages of machine level language. Machine level language makes it extremely difficult to write code and extremely difficult to debug. Now people who started working on computers came up with the idea. They said, instead of using machine level language, why not we use a language where instead of ones and zeros, I use some English like words to represent what I want to do. So for example, instead of writing 000, why not I use the word called as stop. So what happens is, in a next level of language which was developed after machine level language, it was a language called as the assembly level language. This language, too, like the machine level language, is highly dependent on the hardware design of that machine. The reason being, it is almost like writing in machine level language, except instead of zeros and ones you are using English like words, which using a software called as the assembler is converted from assembly language to machine level language. So what this word like stop, start, error, add, these are nothing but letters or symbols. In technical language they are called as mnemonics. Okay, so these start, stop, add all maybe represent the instructions for that particular machine's assembly language. Now if you see here, is this easy to understand or this easy to understand? I'm sure this is easy to understand because it is human readable and understandable. So for example, I am representing stop, all zeros in machine language, which means stop, with the assembly language keyword called as stop. For example, 001 I am representing, which means the start instruction, I am using the word start. So instead of zeros and ones, I am using English like words to achieve my purpose. Now what you have to understand here is, all these words start, stop, error, add are all examples of symbols or mnemonics in an assembly level language, or they are the instructions in assembly level language. This is not a real language. I've just done it so that you get a conceptual idea of it, because once you understand this, it is really easy when you actually use an actual assembly language. Why it is considered a low level programming language? Because if you have got to write code in machine or assembly level language, the knowledge of the hardware is extremely important, because you need to know how many registers are there in the CPU, what is the memory size, how many bits it can process at a time, Okay, where does it store data in the memory, which location from memory to read, all that details you will need to know. That's why, since you need to know the details of the hardware, it is known as a low level programming language. Now, as I told you, the software written in assembly language does not make sense to the CPU. It has got to be converted into a machine level language, and the software which converts this chap into zeros and ones is a software called as assembler. It converts a language written into assembly language into machine level language. Now you may be thinking that machine language is not useful. No, it is used in still very critical parts where it is required that code should run extremely fast. But as I said, the code is highly dependent on computer architecture.